Hey guys, so today we're gonna be taking an old Axii that I had that was broken, this guy here, and putting an rp-sma end on it. I'm gonna make it into a stubby. Here's an example of the Axies. This is an rp-sma. This is an SMA. You probably can't see it very well. The SMA has the pin in the middle, rp-sma does not. The rp-sma is labeled with the red heat shrink. They're a total of 70 millimeters long from top to bottom of the SMA. And here, this guy I messed with, I tried to attach an SMA end on it. This was the first attempt. It didn't work out very well. It just doesn't get a good reception. It was a pretty piss poor job. So we're gonna get rid of that guy. And I'm going to solder this on. I'm going to cut it off and make it into a stubby. Now I was able to pull this off. I've got a bunch of these old Intel 2.4 5 gigahertz Wi-Fi antennas. And they're great. This cable is nice and long, so I can use this cable for all kinds of fun stuff. These ends work out really great for doing projects like this. So there you go. And you get 2 per unit, so I don't know how much those cost or if there's any laying around somewhere that you guys might be able to find, but in any event, if you can find them, they're awesome to play with. So, first things first, get the cable prepped. It had a little plastic sleeve covering the cable. Here you can see that guy there. You can leave that on if you're going to use the length of the antenna wire here. It's good for, keeping this end from getting damaged right here on the end of that metal, but I'm going to be cutting her off pretty short, so I decided to get rid of it. And so I'm going to get this end prepped, and I'm going to get this Axii disassembled, and then we'll start soldering up. Alright, so we'll start with the Axii. To get started with the prep work on the Axii, it's really not bad. You want to remove the bottom piece here, separate this cap. Now on a normal Axii, you just be able to run like a hobby knife or something along the seam here and just kind of gently pry those apart. I've got to remove this heat shrink here since I've already been messing with it. That should be good for now. Alright, and then just find that seam. You don't need to press real hard. Your blade should fit right in there, and then you can just kind of roll it. This one's been glued back together. I had to glue that cap back on. Had a real bell ringer of a crash, and the cap had gotten separated and kind of broke a little bit. And if that ever does happen, it's good to use some kind of removable silicone. This is the stuff I use, and I swear by it. I absolutely love it. It adheres really well, and it removes without a mess. So if you ever do need to take it off, it comes right off. There's no junk, there's no nothing, it just comes right off. Well, you have to pull on it, obviously, because it's an adhesive, but it holds perfectly. And it comes off with no trouble. It's just wonderful. I love it. So alright, well here is inside the Axii. You can see that it is it's got this central board here with these leads that come out and make contact with the active element here. It's, if you've ever seen the inside of like a Triumph, this is essentially the same idea with a different application. So you've got your arms that come out here, and then there's like this PCB ribbon type material that's got metal contacts in the ribbon. You can see it's kind of a darker area there. And so the arms come out here, and there's little solder joints, and then they make contact with these, so they kind of have that, you know, the arm that comes out and then it's like welded or soldered kind of like that. It's a really brilliant idea, and obviously it works really well. So nice small antenna. It's just an overall great design. So anyways, cap's removed. Now we need to be able to separate this lower cap. It just slides down on the antenna shaft. On the normal Axii, it just slides. You don't have to cut any of the cable or do anything like that. It just comes down. On mine, however, since I've already been in here tearing it up, that's not the case. So here you can see this nasty solder joint. That was never meant to be permanent, by the way. That was just a test. So I'm going to remove this end I've already got on there, and then I'll start to prep it for attaching the other one. And I'm going to go ahead and edit that part out because it's boring and it'll probably take a little bit. So yeah, and it's obviously not a step that you will probably need because unless your antenna has already been messed with, then it's not applicable. So we'll be right back. Alright, so I got the end off. This cap, bottom side of the cap, fits on it over the cable like this. Once you remove that, this is what you're going to see. It is, you can't see the light there. It is the shielded part of the cable with the rubber outer coating. So once you remove this rubber coating, and this is the coating on the that comes on the Axii. This isn't like a heat shrink or something that I'd put on there from earlier. Alright, so this is the cable that is on the Axii. You can see that the outer braided shielding is soldered to the leads on the bottom side of the Axii, and the core, the centerpiece wire there, the active element, goes through a hole and is soldered to the top side contacts. So what we'll do here is, I'll get my solder sucker ready. You'll need a solder sucker. Highly, highly, highly recommend one. It doesn't have to be anything special or expensive. These things are like dirt cheap. In fact, you usually get one with your soldering iron, depending on the kit you get. So they get clogged after a while. Well, that's cool. So what you're going to need to do is make sure that make sure it's clear, so in that way you can actually get the solder removed. So alright, solder sucker's ready to go. Cocked and ready. So the first thing I do is use one of these little guys here to hold it. Get your solder sucker ready. Heat the top solder and get it nice and melty. And then get it removed. Sometimes when you're removing solder, it helps to add a little solder, so then that way you can introduce some new flux into the solder that's there, depending on how it was soldered at the factory. It might not have had very much flux in the solder, they might have burned some of the flux out. It's just, if you're having a hard time removing it, just add a little bead of new solder, and then you can use your solder sucker and draw out the solder that's there. Okay. I think that'll work well enough for now. Yeah, I'm not going to get any more out of it. Alright, so we'll turn it over and essentially do the same thing on the bottom side. Now it's got four contacts where the solder is, one for each leg of the active element here on the bottom side. So to remove this, it doesn't have to be pretty, you just want it to be out of the way. And so what I'm going to do is, here, I don't even need those actually, I can probably just do one thing. Use some type of a poker or a knife with a blade that you don't care about, but you want to melt the solder and then move the metal away from it, so that way when it dries it doesn't or whenever it cools it doesn't reattach. A solder sucker is probably going to be useful for this guy too. A solder wick would work too. If you don't have any solder sucker, solder wick might be easier to get down inside there. In fact, I'm going to try that. So I'm just going to lay a little piece of solder wick on top of the solder and see if I can bring it in. So be sure when you're doing this, be careful not to touch the cable, or not the cable, I'm sorry, the ribbon here with your soldering iron, because you can burn it. And then depending on how bad it is, it may not be usable. Alright, well, solder wick is a no-go. I'm just going to go this way. There we go. So it didn't take a lot of heat. Looks like I was able to remove it just holding the soldering iron in kind of one place and moving around a little bit. It melted the solder that was on the outside of that braided material pretty well. And then also melted the solder from the active element on the top side. So you can see here the shielding has got solder in it, and then the active element pokes out just a tiny touch to go through the PCB here and to the top side. So you want to make sure that there's no solder that bridges the bottom area to the top side, because those are going to be two separate solder joints, and you don't want any continuity there. You don't want that to be all separated, and we can check that with the voltmeter after the fact. So now we've got this removed. You can solder on your end, and you can use any end. When you're using the antennas, the antenna cable. The cable's all essentially the same, it's just the end is going to be the difference. So if you're going to use an MMCX or a UFL or an SMA, once you know, the cable has a braided shielding on the outside and the active element on the inside. The end is the same, so it's just the size is different. See, so for example, this is an MMCX end, and the cable's smaller, but it's still the same. The outside's got, you know, the coating, and then the inside's got the shielded metal braided material, and then the inside's got, you know, the active core, and so the process is going to be the same for all ends that you solder on. So you can use, you know, anything. If you've got an SMA and you get a VTX that's got a different end on it, you can use an old, like a receiver antenna, cut the UFL off and put that on here. It's whatever you want. Now, as far as the length of the wire that you're, the cable you're going to use to mount your end on, I've been told and I've read through some moderate research that the shielded part doesn't make much difference for what we're doing in the performance of the antenna. Now, I don't have any kind of a degree in RF anything. I don't have any kind of formal knowledge about it. I've done a lot of independent research. I've made a lot of antennas. I don't have any way to test, compare lengths, this, that, or the other. But what I do is I try to keep them in, you know, quarter or half wavelength just to be on the safe side. And also I just use the same measurements that the manufacturer sends their antennas with. So if I was going to make this a full length Axii, I would use the same length that this comes with. I think I've measured it out and it's like 63.5 millimeters of cable from the end of your SMA, and then that'll give you a total length of 70 millimeters when the unit is finally finished. Just do your measurements, but you can make it any length you want. I really don't think that it makes much difference, because for example, you get a Mach 2 with the MMCX or UFL adapter, and it's got the adapter on it's like 50, 60 millimeters ish, and then you attach your Axii that's 70 millimeters, and so your length isn't changed. And I don't believe that those adapters are made to half or quarter wavelength, but I'm not sure. So in any event, I'm saying I don't think it makes any difference how long the shielded area is, but I can't guarantee that. So if you have any doubt, use the manufactured length or the manufacturer's length, or just give it a shot, see what happens. I mean, what's the worst case scenario? You just have to trim it up a little bit. So there you go. So for what I'm going to be doing, I'm making this a stubby. So I'm just going to cut this sucker off low-like and then put this guy straight on. So what you're going to want to do is get your end prepared. Now, I need to think about this for a second and see exactly how much cable I'm going to need. See, so I'd like it to be like that. Just stick it straight on. And then I can maybe use some heat shrink or something around this area. It'll be kind of tough, but it's doable. So, alright. Okay, so when you start off, give yourself a little length to trim. The shielded material that's under this plastic outer coating is really fragile. It bends easily, but it breaks and tears very easily. So make sure you give yourself a little length. And also, if you need to make an extension, you can kind of remove some from another length of the cable and kind of solder it on. It is a little difficult, and sometimes it can make it ugly, but it'll work, so whatever. Alright, so I'm going to give myself, that's about double the length I feel like I'm going to need. Cut that guy off. I'll save that cable for later. I'll probably use it for something fun. I usually do. And so with this, I'm going to remove this plastic outer coating, but I'm not going to go all the way to the base here. I'm going to leave just a tiny touch, so then that way my active element here isn't sitting straight on the metal piece, which would be fine, but my fear is that the shielded metal material will be weaker if I remove all of this plastic. This plastic outer coating kind of holds it in place. So I'll leave about a millimeter or two on there just to give it a little bit of a buffer. And be very careful when you're cutting through this stuff, because if you cut too deep, you'll cut that shielded material, and then you've either got to use another one, or you've got to try to solder on, like splice on some more, and that makes it kind of ugly. And it's just a pain, and it could impact performance as well, so just kind of be careful. I just set the blade on and put a little pressure and just roll it, and just let the knife make a deep score, and then make a cut out, so that way I can kind of just tear along the score. There, just like that. See, I was able to save some of the material. I didn't cut through the braided material. Everything looks nice. Alright, so this braided stuff moves really well. It just kind of collapses down on itself. So you can move it like that. Once you start to kind of expand it, then it usually wants to break and it doesn't expand very well. So what I'm going to do is kind of just move it back with my knife a little bit. So on the bottom of the Axii, it's got those 4 arms. Or 4 leads, I should say. These here. And so I'm going to make 4 bundles of this braided stuff to coincide with those. So then that way you can solder it all up. Okay, so now that it's laid out, I'm going to try to get this as equal as possible and just get 4, separate this braided stuff into 4 little arms here, as equal as possible. It doesn't have to be perfect, I don't believe. And they don't have to be real tightly wound, you probably want them to be a little looser, just so they kind of cover a little bit more area. This stuff here is what mitigates your interference by shielding the antenna. Just think of it as a type of Faraday cage for your active element here. And so the more coverage you get around the active element, the more RF interference you can block. So, alright, there we go. Not bad. Alright. So there's that. Now to trim the active element. The active element on the piece that came from the factory that was soldered on looks to be about 2 millimeters. That sticks up through. So I'm going to give myself a little bit of headroom and make mine a tiny bit longer than that, and then that way if I need to trim it down later I can. There's really no reason it has to be exactly that same length, I mean just so it can make contact and solder through. So if you make it exactly the same length and then you have a problem, then you're in trouble. So like I said, I'm going to give myself a little bit of headroom here. There. Now you can see I've made mine about twice that size. And so this is the same process with removing the shielding from this stuff. You just want to use your knife, make a score, and then I just kind of pinch it off. So here I'll show you if this is still in frame. I use the edge of my table, make a score where I want to pull the plastic coating off with my knife. Just make a deep enough score that it will cut, but not so deep it actually makes it to the wire. Turn it over and make a second score mark in the same place, and then that way you can usually pull it with your fingernails and remove it. Now, since this is attached to the receiver of the active element on the inside here, I don't want to pull on it, because what ends up happening is you pull the center of that cable out. Here I can show you. This is what is inside that cable. You can see it's just a little copper jacket here that's got a hole that receives the center post from your SMA connector, and it's soldered to the active element wire, and this just runs up through the center of the cable here. That's got the shielded Faraday cage kind of deal. And so this thing isn't secured in here really by any other force other than friction. I mean, it doesn't have any kind of glue or anything, it just is in there. So if you pull on this guy, you're going to pull it right out. Now you can slip it back in, that's not the problem, but when you do that, sometimes you can mess up the braided material or whatever, so you just got to be careful removing this plastic stuff. What I have found helps a little is you don't want to burn through it, you just want to heat it up a little bit just to make the plastic a little flexible. So with your score marks, just kind of a little heat with your soldering iron, and then that'll make it real easy to remove. Just like that. Okay, so you want to make sure now that all of this shielded stuff, it doesn't have any stragglers that are kind of hanging out or can go up and make contact with your active element. That would be bad. That would be bad, I'm good. Alright, so we're going to go ahead and tin everything up. Now be careful when you tin the active element, the center post here, because if you use too much solder and it gets fat, then it won't fit through the hole there. You just want to add just enough solder so that it coats and gets down inside. So then that way whenever you solder it up, it has something to stick to, obviously. Hopefully if you're attempting this, you understand the idea of tinning. And then we're going to do the same thing for our shielded material here. Now with the shielded material, this stuff can take a lot of solder. So you don't really want to use a whole lot of solder yet. You just want it to be enough that it the solder that we use down inside this guy here has something to stick to. And then also, this will give you, it'll give the shielded material some rigidity so you can trim the excess off. And then everything will fit down inside much easier. Obviously you're not going to be using this much of the shielded material down inside that guy. There. So you can see now that I've just put a little dab of solder on each one of the arms, and it doesn't even go all the way through. It's just a little bit of solder just on top of the wires. You can melt it down inside if you want to. It's really just kind of not necessary at this point. Like I said, we just want to put a little solder there just to tin these wires up, and then also to provide a little rigidity since this wire is so thin and brittle. And the rigidity is going to help for trimming. So I use fingernail clippers for trimming wires. I think it's much easier than trying to use actual wire cutters like these big guys. Scissors work really well too if yours are sharp. Mine have been used for 35 years, so they're not. So I'm just gonna clip. And then, like I said, make sure all of your shielded material doesn't have any flyaways, because that really thin wire, it has a tendency to break off and then pieces get all over the place. And if you've got one making contact, then you've got continuity through the both, and then that'll cause performance issues at the very least. It could even cause a short or break something somewhere. I don't know exactly what will happen. I've never had it happen, luckily. Hopefully I don't ever have to worry about it, but that's neither here nor there. Alright, so it looks like everything fits well. I need to trim down a little bit more of this plastic shielding for the active element. It needs a little bit more. I need to sit it down a little bit more. So I'm just going to do the same process here, just kind of trim down just a tiny touch, and that's probably not even a full millimeter. But just kind of make a score mark with your hobby knife and roll it. I don't even score all the way down to the wire. I just get it close because this wire is really soft. You can cut right through it with a sharp razor blade, no problem. Alright, so the score's there. It's my trusty soldering iron. Then remove it, just like before. Alright, everything's good. So, needless to say, you don't want continuity between the shielded material and the active element. So, with that in mind, make sure that when you trim this shielding or this rubber coating off of the active element wire, that there's still enough that it provides protection for the active element. You want it to be at least a millimeter above the shielded material, because once you get it done inside there and you start to solder it, it'll move, and sometimes if you get like a fat solder ball, it can make contact in there. You don't want to risk it. You know, having to get this thing out once it's already in is a pain. It's possible, so you can change the end later if you'd like to, but it just is easier if you don't have to. So there you go. So alright, so everything fits. I'm going to put this thing back the same way it came in. You can notice that this ribbon that's wrapped around the outside has got a lip that is a little bit wider on the bottom side than the top side. The top side here seems to be, oh, I don't know, 3 millimeters tall, maybe 2 and some change, and the bottom side's a little bit thicker, and that might be a full 3 millimeters, maybe 3 and some change. Whatever, doesn't matter. So anyways, you want to put it back the same way it came off. So we're gonna stick it on just like that. Oops. Line up your contacts on the bottom side here, so then that way your arms meet up with the contacts on the inside, at least close. In fact, you can even tack one of those down if you'd like. I'm not going to for now. I'm just going to solder on my active element. Obviously this thing's turned a little bit, but we'll see how it goes. So you don't need a whole lot of solder, just a tiny, tiny touch. I'm going to use a little bit more just to reintroduce some flux here. Make sure it sticks well. That is good to go. So with the active element done, you can trim the excess from the center wire here from your SMA or whatever adapter you're using. You don't want that guy sticking up too far because we're going to recap it. And I've already made a mistake. I'm glad I caught it just now. So, bonus points to anybody that can tell what I forgot. Yeah, the bottom cap. I do that more often than I'd like to admit. So, boys and girls, bottom cap will go on before you start making these arms. Damn it. So if you're dumb like me and you've forgotten your bottom cap, then you'll have to carefully loosen your solder or melt the solder so that way you can bend these arms up and put your cap on. Luckily I didn't use much solder. And this guy just slips right down, no problem. And this would also be the time that you want to put on your heat shrink. If you're going to. It can go over the base of the SMA, but as you can see, the difference in size makes it kind of difficult. Your heat shrink might not shrink down far enough to really give that a nice fit. So I'm gonna see if I've got any of that size heat shrink left. I use miles of this stuff, so I'm not sure if I've got the size that I need. We will see. So the cool thing about this heat shrink is it stretches really well. If you don't have a right size, like I don't, you can stretch the stuff you do have and it'll still shrink down to the size that it was intended to. So if you've got, like 3mm stuff and you have to stretch it out, it'll still shrink down to 1.5 or 1mm depending on the ratio of the stuff you've got. So, okay. Now, we can actually affix the top part here. Alright. So for real this time. So with this bottom cap in place, soldering this bottom part is going to be a little challenging. Not impossible, but man, there's not much room back there. So you can see that with the heat shrink, there's like not much room at all. So it looks like it might be a good idea, if you are going to use heat shrink, to go ahead and shrink it down over the area that you want to before you get it completely assembled, because this is a very tight fit. A very tight fit. Okay. So it's not so tight it won't move, that's good. But it is definitely going to be challenging. Alright. So what I'm doing now is I'm just kind of re-wetting these solder joints just to make sure that if any of those wires broke when I was bending it, that they're good to go. And also to make sure that if there were any that broke, there's no flyaways that are making any contact or even close to my active element here. So, alright, I'm going to reaffix the top guy, hopefully for the last time. Reintroduce a little more solder just for the add a little flux in. I can tell by looking at the solder it's kind of doing the ice cream cone thing, so it needs a little flux. There we go. I think that'll work just fine. Okay, so now for the fun part. Now we've got to get in between the cap and this ribbon to solder the bottom areas. So let's see how much room we've got. Move this cap all the way to the bottom. My 9-year-old daughter's phone is ringing 1 o'clock in the afternoon. She's at school. Who could possibly be calling a 9-year-old in the middle of the day? Don't even think about that. Alright. So anyways. Alright, so what I think I'm going to do is I'm going to give this just a slight bend. Yep, that's no bueno. In order to get the iron down in there. Now, a smaller tip might be advantageous. I've got some smaller tips for this iron, however, I'm not going to mess with it. Just going to see how this works out. And there's like no light down in there either. No, that's not so bad. So it's a good idea to tin those little contacts inside before you do this. As I am experiencing, it sticks okay, but it would have stuck better if I had tinned those contacts area. So that's just something to keep an eye on. So it helps, I'm finding, if you kind of give it a little bit of a bend, and then you can kind of get your iron in there a little easier. And when you are bending it, you know, it kind of forces the leg down on the contact a little better, and you can verify that it's actually made contact. It's actually stuck. You know, when you're moving it around a little. And also it gives you a little bit more clearance here to get down inside there. Okay. Okay, so everything's soldered back up. It looks good. It really wasn't that bad. There was more clearance in there than I thought. You've really got to be careful not to bump the plastic cap and distort the edge, otherwise it might not fit back on well. But in any event, there you go. It's back on. So what we want to do now is use our trusty voltmeter, set it to ohms. Doesn't really matter which ohm voltage or setting you use. Ohms are what you're going to use in order to test for continuity, which here we don't want continuity. You can see my voltmeter is a reading of 1 right now, with the contacts separated. If you do have continuity, it's going to be 0. There you go. So if you put your lead here on this contact here, and your other one on the base, you should get no change. Perfect. That means there's no continuity and we're good to go. You can touch it on your solder joint here in the middle just to verify. Continuity, no. Great. So now you want to touch it to the center, the active element on your connector. If you're using the MCCX, it's going to be that little pin in the middle. Same with the UFL. SMA is going to be the pin, obviously. rp-sma is going to be the hole. And then touch it on the bottom, or on the active element, we should get 0. That's continuity. Yep, that means that we're good to go. Alright, so our voltmeter shows that we do have continuity where we need it, and we don't have continuity where we don't need it. All of our joints are soldered up well and nicely. You want to use a dab of your preferred adhesive in order to secure the cap back on. But other than that, there you go. Your fancy new Axii stubby, or with your preferred connector on it, ready to go and test. Hope that helped. Enjoy.